So, in the last lecture, we have seen different types of load, and we have seen the single phase uncontrolled half wave rectifier. There it was there in the last load which we have discussed. There we have seen your RL load, and we have told that the as you are increasing the inductance value, your current waveform will increase, okay, and it will become continuous and discontinuous means continuous, that it does not touch your zero value, and if the current touches the zero value, that is called discontinuous. Okay, now here we have explained that for this load we have your L di by dt, means the voltage across your inductor was Vs minus Vr. Vr is the voltage across your resistance. Okay, so if you do the Vs is this voltage, and your VL is the inductor voltage. So L di by dt is Vs. Now if you can say that if di by dt, or you can say if Vs is greater than Vr, di by dt will be increasing. Okay, and if the reverse condition happens, that is Vs is less than Vr, di by dt will be decreasing. Now here if you are seeing the Vr value till here, till this point, Vs was increasing, Vs was at a higher potential and Vr was at a lower potential. After this, Vs was at a lower potential and Vr was at a higher potential. Okay, so that's why the waveform was attaining your peak value, attaining the peak value before, you can say that this is the peak value, and then it after that this peak value it starts decreasing. Okay, so this is the waveform, and because the inductor has extra energy even after pi, it makes your diode, because after pi your inductor still have extra charge. So initially you can say that the inductor charge was stored like this, and as inductor does, and the current is coming like this, right? So I'm again once upon one I'm explaining once more that inductor does not change, allow the rate of change of current. Okay, the rate of change of current, that means if the current is flowing in this direction, it will never allow the current to flow in this direction, reverse condition. Okay, so that's why during the charging condition what happens, that inductor charges with this polarity VL, and the current is coming from this side. Okay, that's why we are writing dL I by dt. Now once it got charged to the maximum capacity, it's now need to get discharged. So how it will be discharged? So the current will be always in this direction, because inductor will never allow the change in the current path. Okay, so that's why the current will never change the direction. But what happens to the polarity? Polarity changes. Polarity changes. So this is the charging cycle, charging, and this is the discharging. Okay, so that's why the current never changes. Current direction does not change, but your polarity does change. Okay, so that's why here if you see during the charging condition, the current direction is this, but during the discharging condition the current must be in this direction only. So the current direction must be in this direction. That's why the polarity got reverse. Polarity will be changing. Okay, so polarity will be changing. So this polarity will be minus and this will be plus. So that's why the conduction, and because of this, because of after your pi, your Vs is in negative side, that is Vs is less than Vr, and your inductor has larger energy. Because of this, the most of the voltage appears across your diode. Even your supply voltage is reverse condition, your inductor is in forward condition, because inductor makes your diode in a forward condition. That's why this negative charge, negative cycle comes in your V naught. That's why your diode is still forward bias. That's why the diode is conducting. Okay, now because diode has extra, you can say that the pressure, because diode does not have a nature to conduct in the negative half cycle, but it is conducting because of the voltage across your inductor voltage is high from pi to beta. Okay, so what happened, people did that, they replaced, they attached one more thing. Whenever they are connecting an RL load, they always connect one extra diode across the RL load, and this is called as freewheeling diode. Okay, this is called as freewheeling diode. What it does, that when your inductor wants to discharge, it will discharge through freewheeling diode, not through your main diode. Okay, so uh, because of this, the cycle from 0 to pi remains the same, but from pi to beta, your output voltage is shorted. Because what happens, because your freewheeling diode starts conducting, and that's why this freewheeling diode starts conducting, that is your forward, it is in forward condition, and your main diode is in off condition. So what happens to the voltage? For your voltage, the voltage is short, V naught is 0. When your this V naught is 0, right? So V naught is 0, that means the output voltage from pi to beta will be 0. Pi to beta will be 0. So therefore, whatever the your diode, your main diode does not have to operate for a negative half cycle. Okay, so that's the advantage of attaching a freewheeling diode in across your load. What happens, that the negative part is removed. Okay, so the all the rest of the voltage of your diode, of your freewheeling diode operation, is only when you have an RL load. So because of this cycle, what are the advantage of connecting a freewheeling diode? Advantage of connecting a freewheeling diode. First advantage is that the this current waveform has a continuous current waveform. The load current is continuous. Okay, but what about the source current? Source current is interrupted. Source current will always follow the Vs curve. Okay, it will have like that. So that by connecting a freewheeling diode across the load, your this load current becomes continuous. Like if you increase the inductor value to a very high value, so whatever value you connect, so if you increase the inductor value, your continuity of the current can be increased. Because if you in the last lecture I have explained that to make the output current continuous, you have to connect an inductor, and the continuity of this load current does not comes in your output voltage. Your output voltage will be, for a positive half cycle you will get a voltage, for a negative half cycle if you have a freewheeling diode it will be zero. Okay, now you will ask, sir, why we require a continuous load current? Okay, you want a continuous load current because your torque is completely dependent on I naught. Okay, now this RL load is nothing but your motor load. Okay, motor load. Motor has a torque, and torque is directly proportional to which current? That the load current. And you if you want a continuous torque, you want a continuous current. Okay, so that's why if you connect a freewheeling diode and have a large inductance, the solution to a torque issues, you don't have a discontinuous torque, you have a continuous torque, so you will require continuous current. Second advantage is that your input power factor is improved. Input power factor is improved. Now what is the input power factor? You can say that input power factor is the power delivered to the load. Power delivered to the load V naught into I naught divided by power delivered from the source Vs into Is. Okay. Now, your if you have a continuous current, definitely your voltage, your you can have large amount of I naught value of I naught, RMS value of I naught will be high, right? RMS value of I naught will be high. Therefore, your input power factor increases. Okay. So this is one of the advantage of your connecting a freewheeling diode. Okay. I hope it's got clear for most of you. Okay. Thank you.